Hello everyone, this is me Mithuna again from Coimbatore Medical College. Today we are going to learn about two topics, lung volumes and capacities and ventilation perfusion ratio. Through to the first topic. First, let us see about the definition of spirometry. It is the study of pulmonary ventilation that can be done by recording the volume movement of air into and out of the lungs. This is done with the help of a basic spirometer. Now, let us see about a spirometer. It consists of a drum which is inverted over a water-containing chamber with the drum counterbalanced by the weight. The drum contains oxygen and the chamber contains water. This is the counterbalance, and there is a tube which connects the mouth with the gas chamber. This is the mouthpiece. When one breathes into and out of the mouthpiece, the drum moves up and down. This movement is recorded in a piece of moving paper. Here I have labeled all the parts: the floating drum, oxygen chamber, mouthpiece, counterbalancing weight, and the recording drum. The recording drum is where the spirogram is recorded. Now let us see about the pulmonary volumes. First, tidal volume. It is the normal amount of air that we inspire and expire normally. It is around half a liter, that is 500 ml. Let us remember like this. Next is inspiratory reserve volume. It is the amount of air that we extra inhale after normal inhalation. That is after normal tidal volume. It is almost 6 times that of the tidal volume. So remember 3000 ml. Next, expiratory reserve volume. It is the amount of air that is expired forcefully after normal expiration, that is normal tidal expiration. This is around 1100 ml. Next volume is the residual volume. This is the volume of the remaining air which is left after the most forceful expiration out of the lungs. This is around 1200 ml. Now, if we see, both of these volumes are almost around twice the tidal volume. So remember it like this. They both have just a difference of 100, where residual volume has 100 ml more than the ERV. Now let us see about the pulmonary capacities. It is the combination of all the pulmonary volumes, either 2 or more than 2 pulmonary volumes, which form the pulmonary capacities. First, let us see about the inspiratory capacity. It is tidal volume plus the inspiratory reserve volume, that is 500 plus 3000, approximately 3500 ml. It is the amount of air a person can breathe in beginning at the normal expiratory level and distending the lung to the maximum extent. Next is the functional residual capacity. This is the amount of air that remains in the lung after normal expiration. So both the expiratory reserve volume and the residual volume comes. So it is around 2300 ml. The next is vital capacity. After filling the lungs to the maximum, that is tidal volume plus inspiratory reserve volume, the amount of air that is expelled forcefully, that is expiratory reserve volume. This is called as the vital capacity. Thus, IRV plus TV plus ERV all together form the vital capacity. It is around 4600 ml. Total lung capacity. This is nothing but the vital capacity plus the remaining residual volume. That is the maximum amount of air that can be held in the lung with the greatest possible effort. That is the total lung capacity. It is around 5800 ml. Here is an important thing to note. Residual volume cannot be measured using spirometry. So neither the FRC can be measured. So they are indirectly measured using the helium dilation technique. Here, the person is connected to a spirometer filled with 10% helium and oxygen, and the person breathes from the spirometer. After repeated breathing, the helium concentration in the spirometer and the person's lungs equilibrates. That is, on applying the conservation of mass principle formula, we get C1V1 is equal to C2 into V1 plus V2. Here, C1 is the initial concentration of helium in the spirometer, whereas V1 is the initial volume of oxygen mixture in the spirometer. V2 is the helium concentration after equilibrium, and V2 is the unknown volume in the lungs. So therefore, that is how we find out V2 using this formula. Here we can see the volumes and capacities as spirogram. You can see the IRV, tidal volume, expiratory reserve volume, residual volume, inspiratory capacity, vital capacity, FRC, and the total lung capacity. The blue color on the left side all are the volumes, and the right side green color are all the capacities. Let us now move on to the second topic, ventilation perfusion ratio. This is another short note. What is ventilation perfusion ratio? It is the ratio of the alveolar ventilation to the maximum amount of blood flow in the lung. In normal individuals, the alveolar ventilation is around 4 liters per minute, and the pulmonary blood flow or the perfusion is equal to the cardiac output or the right ventricular output, that is around 5 liters per minute. Therefore, the normal ventilation perfusion ratio is equal to 0.8. Now let us see about the regional differences in the ventilation perfusion ratio. In the upright posture, normally the base of the lung gets better perfusion and ventilation due to the gravity. So the difference in blood flow between the apex and the base is fivefold, whereas the difference in the ventilation between the apex and the base is twofold. Thus, the VA by Q at the base is 0.6, whereas at the apex is 3.6. At the base, there is more perfusion compared to ventilation. Thus, some amount of blood circulates without becoming fully oxygenated, whereas it is opposite at the apex. So, there is a high alveolar oxygen tension and low carbon dioxide tension at the apex. Here we can see the variation in difference between the perfusion and ventilation as the base and the apex. Compared to the apex, the base is both well perfused and ventilated, but perfusion is higher than ventilation. But at the apex, ventilation is higher than the perfusion. But both of them are comparatively lower than at the base. Now, let us see about the clinical importance of VA by Q ratio. Due to the regional differences in the VA by Q ratios, some diseases are more localized to some part of lung. For example, pulmonary TB is more favorable at the apex because the apex is a favorable environment for M. tuberculosis due to high oxygen tension, which facilitates the growth of the tubercular bacilli. Now let us see about a related topic, which is venous admixture. It is the mixing of unoxygenated blood with oxygenated blood. Let us see why it occurs. It may occur due to two reasons, either due to shunt or due to low ventilation perfusion ratio. Shunt may be anatomical, like in atrial septal defect or ventricular septal defect, or physiological, where the deoxygenated bronchial blood venous blood mixes up with the oxygenated pulmonary venous blood. Where low ventilation perfusion ratio, like mostly at the base of the lung, here the pulmonary capillary blood is not oxygenated properly due to the low alveolar ventilation. I hope you like this session. Thank you.